I start with, so the idea of using HeighField. So HeighField is a new tool in Houdini 16, a new addition, but it's based on the volumetric calculation. What does it mean? So far, if we wanted to create a train, so there were a couple of options. So one of the very good way of doing it was like applying the train operations on a geometry. So let's say you create a geometry, a dense one, so a geometry of 500 by 500. Okay, so it's a pretty dense geometry, and you start applying. Hello, hi Perik. We just started. So applying a so let's say we start applying a noise on a geometry. So I drag that, press tab, and attribute VOP attribute let's say I want to attribute VOP. Yeah, that's the one. My bad spelling. That's all right. So so the VOP, you know that it's just a visual interface for programming. Well, not programming, but just like creating nodes and math within that. So it's pretty much similar to Unreal Engine blueprints, so that you do your operations visually. So let's say I want to, so I have this position of every particle. So this is, well, nothing happened now. So I say I want to add an operation. So now it means that I want to add to the current position of our points something else, like a noise. So let's add a noise, like a, I don't know, a turbulent noise. So I add a turbulent noise. I grab the position P to P and send back the noise into the input 2. So the HeighField is getting added to that one. It's just a simple train. And the point is this. If you middle click on that, you will see that you have generated about like 250,000 polygons and 1 million vertices, and you have occupied 20 megabytes of your RAM. That's massive. That's a lot of data for a simple train. Just imagine that you want to make a game level, and it's massive. It's so large, and so the amount of memory that you will occupy will exponentially increase so much. So one way of dealing with that was like, instead of using polygons, so you see that every one of them, every little one of them are one single polygon. But if you say I'm going to use a polygon soup, so not a big deal, not a big change, but you will see that the amount of the memory just dropped to 12 instead of, so polygon was 19. Polygon soup, that considers them as an integrated entity. So we have now one polysoup, and the memory just dropped down. But how does that work? How do you go from polygon to polygon soup? Just change here. How does it affect the post-processing on top of the node? Like, what kind of data is not being stored in a polygon soup to make it light? I don't know. Okay. I don't know the underlying math behind that, to be honest. And I don't use polysoup quite often, so that's why maybe I should use it, and I have to go read. And okay, so if I start with a volume, so you know that lots of things in Houdini are volumetric, like fire, pyro, clouds, and volumetric entities, they store voxels instead of polygons or points or geometry. So let's say we make a equivalent, so like 10 by 10 volumetric shape. So the idea is that, so before introducing HeighField, it was like, okay, we are generating volumetric shapes. Why not generating volumetric surfaces? So it means like a 2D volumetric surface that stores the height information instead of like fuel or density and stuff like that. So so let's say we have again like 500 dense polygon. It's two-dimensional and it's like ZX maybe, and in the properties it will be instead of smoke or rainbow or whatever, it would be a HeighField. So you see we have a surface, it's massive. So if I command spacebar F or Alt F, you will see that because it's huge. So if I apply the same operation, so if instead of attribute VOP, so vex operation, I apply a volume tab, volume VOP. That's the one I want. Okay. So, and within the volume VOP, we do the same thing. So instead of, so we don't need to do the addition here. So we just drop a noise. I use the same noise, turbulent noise, and drag it here. But instead of,
I think it's on type right
now. Yeah, it should get into position. So density or position to position. Yeah. So we're not dealing with density or other attributes. We just want to do the same thing. So that's position. So we have kind of the same train, but look at the amount of space that it has occupied, 1 megabyte. So it's just 1.1. So you see, there's no polygonal information stored, but we have voxel information stored. We have 250,000 voxel information stored. So that's and the amount of the space that has been occupied is 1 megabyte. Yes.
Would you be able to apply a texture to this?
Yes, yeah, of course. Everything that you can do on a volumetric shape, you can do it here. So it means that you can play around with, so as long as it's a volume, you can play around with the volume. So let's say if you have a massive, so let's say instead of 500, you go 2000. So it becomes like much more dense and much more detailed, but at the same time it occupies 15 megabytes. It's too much. But you know that volumetric shapes, you can compress them. So you can say tab and compress. So volume compress, that's the one. And update compression setting and use, so use 16. So let's say if we compress that, it becomes 7 megabytes. So, and you don't see any noticeable difference. So you see that with, nothing has happened. So even you can start quantize. It means that clip some information. You see that you start seeing some noise, but well, So let's say a very small amount of quantization, like 2%. Again, middle click, it's dropped to 3.8. So we still can manage the information in a volumetric, or you can apply. So let's say you can apply. I'm gonna enlarge this part. Yeah. So you can apply blurriness, volume blur. So you can blur out. Oh, that's too much. So just blur out your, because it's a volumetric shape. So it's very flexible. You can resample that. So whatever applies to a volumetric geometry, you can use that. So that's the idea of using HeighField. HeighField are pretty much the same structure. So let's say we start with, I'm going to turn this off. You can bring in the HeighField shelf here. Where it was. Shelves, train tools. So you see that HeighField noise, blah blah, all of them has been added. Or you can start just typing. Okay, I'm gonna add a HeighField. So when you get in, pretty much, so just pay attention to this connection for the HeighField. It's turquoise, so it means that it's not an object, a geometry way of connection. So most of the time you cannot connect a geometry. Sometimes you can, some of the tools, but most of the times not. And when you press tab and press HF, all of these are HeighField except this one, hair growth, which is fine. We can find our way out. So let's say you have created a HeighField. So it's again, so you see that it provides you a 1000 by 1000 voxel geometry, 2D volumetric geometry. And now I'm going to go through a couple of procedures to create a terrain. So let's say I add a noise. So not a noise, but just a HeighField noise. So or you can just do this. Tab HF noise. So and I select a kind of like let's say whirly noise. So I start with this noise, and you will see that we can add information, HeighField information on top of each other, and the output. You see that we are 1 megabyte still. So because there's not too much detail, but still very efficient. So I add another noise just to see what we can do. So this one I make it add more amplitude and maybe just a bit more rough. So you see that I have combine the previous one, but the previous noise with this noise. What I don't like is this obvious lines that makes it look mechanical. I can add a distortion to make it more organic, like so HF distortion, and leave it here in the middle. So let's look at that one. So distortion. So this is the first noise. It was clean, nice. It helped us to carve the main structure of our train. This one, distorts. So look at that line here. So it just gets distorted, which is very desirable for adding an organic shape. So now this one looks less mechanical. Or you can use different masks. So let's say, let's start from here, or start from the second noise, and type HF paint, mask by object, or no, not that one, HF mask by feature. or you can draw mask as well. I will show you how to do that. But let's see what his mask by feature is. So you see that you can say I'm gonna mask by the slope, you know. So you say I'm gonna mask out this amount of slope, and then I'm gonna apply a different type of noise on that mask. So let's say you say, or you just want to distort it in a different way. So you just distort that one. I'll add erosion at the end. Or yeah, that's a good idea. So yeah, so yeah, erosion just starts. So let's start adding erosion at this time. Erosion. So you can start. So I just wanted to add it at the end to go through all the tools, but it's a good idea because that's how many of level builders start. They start to carve out right at the beginning some sort of like rivers and stuff. So what is erosion? Erosion is a So let's have a look at the erosion. Erosion, well, as it says, erodes your terrain based on some simulations. I just add it at here and then go back to that masked version and apply it over there, just because it looks cooler. Erode. We don't want to get into the. Okay, so you see that it applies just a visualization. The visualization at the beginning is not accurate. You see that? There's a problem here. So you just have to go there and recompute that, or change the way you like it. So these are your debris, and then the snows, and just screens and stuff like that. And then you play it, and then this one starts to erode. And then if you're happy with that position, you just use that one. So let's start applying erosion to this stage before getting into. I just want to erode that part, or the other way around. Just so if I go here and say I want to apply that. Yeah, it's a mask. I want to apply erosion, HeighField erosion. Not in everything, but just in the mask. Erodibility. I don't know if it accepts a mask or not. It has applied to everything. I just wanted to apply just on the red ones. So most of the nodes will read, so let's say a noise. They read your mask right away. So let's say you want to apply a noise, and that noise gets applied on just on that part of the mask, part of your image. But I have no idea about erosion. So the erosion at the moment has been applied on everything. Is there a way to apply it on layer?
Is it that it should have the base HeighField as the first input and the mask as the second input, or something like that?
Yeah, we can do that. Or I don't know. So you said what?
No.
This one is well. Is that the mask one? Erode 2 is, yeah, that's the mask. So if I get the erosion, so yeah, you're right. Sorry, my bad. So I get the erosion from here and mask from here, but that doesn't work.
Maybe it works, but it's inverted here.
Based on what? Okay, mask is our mask is that one. Now the mask has been generated. Let's erode it another time. Let's go to the visualization, compute. I think I broke it. Let's apply it again. Just an experiment. Good question. Good to know that. So we want to erode this height fill noise. Okay. It gets eroded up to here, and that's been masked by. So we have a mask here. So the mask, I'm gonna turn off this mask by height. Okay, and let's name that one. Mask by feature. There should be an okay mask layer mask 1. Oh no, mask. We're gonna use the same layer for, let's say, okay, I'm gonna plug it in and say that for the mask I'm gonna use that one. Let's see. Yeah, it worked. So it didn't erode those areas. So it just eroded the parts that has not been masked. Okay. Thanks for the good question. Okay, let's go over other tools that we have available. So you can layer things on top of each other. So let's say you're happy with this, you're happy with that one, and you want to put them on top of each other. So HF layer is your solution, is your way of putting things on top of each other. So you can layer them on top of each other and you combine them, and you have all these tools, so you can add them on top of each other based different attributes, combine different attributes, and everything, like pretty much like photoshopping your train building. Or one very useful tool is, so you can isolate. So let's say you have eroded this area. So you can say, I just want to HF isolate. I just want to see just, let's say, water or debris or bedrocks. So you can isolate that part. Let's apply the isolation on a nice dense erosion. So I add an erosion here. Come on. And yeah, it makes more sense here. Tab HF isolation. And let's say we want to just see water. So we see the map of that part. That would help. Sometimes you need to just apply an operation on just that specific part, or just flows. You should do that. So you can so let's say this is a different stream. So you can go and say HF output. You can output that as like a PNG, like name.png image. Just export that. Or you can convert. So let's say I just convert that part. HF convert HeighField. So I convert my HeighField into polygons or VDB. So if you load VDB for rendering in V-Ray or Redshift, or you can convert. So let's see if we can convert that one. Yeah, so I have two geometries now. So
Size of that.
so this geometry is like huge. It's 53 megabytes. Occupies 53 megabytes of RAM, and it has 250,000 polygons. And but this one should be, no, it's the same. If you want to export your height field to another program like Maya or game engines, you can convert height field into a polygon here. I believe game engines can read height field, but if you need the geometry, the actual geometry, you can export here. And there's a nice feature. It was if I want to output my height field, that grabs the coloring resolution. So let's have a look at that one. Yeah, you can grab the map if you want to output a bunch of UDIM like tiled maps, or just export an image. And yeah, we had a nice feature. So if you want to extrude the base, that would, if you want, let's say you want to print it out, or you want to use that geometry somewhere else. Polygon. There was some baked point colors. Yeah, that's the one. Yeah. Now I have point colors baked in. Let's recompute that one too, so we get a nice. Yeah. So yeah, you can export that. So this geometry, once it gets exported, it comes with the color data as well. Or you can, so let's say you're happy, so as long as you are within Houdini, or as long as the other software like Unreal Engine can read height field, you can keep it as height field. You don't need to convert it to a geometry, actual geometry, in terms to save a lot of processing power and memory. One really nice feature to prepare it for exporting out is height field quick. So tab height field quick shade. So this quick shade will let you to do a simple texture, like if you want to paint your texture in another app like Substance Painter, or just apply a tint. So I just apply a tint here for the mountain. Oh, no. And add, let's say, I select a debris. We can start from down to top. And I add a texture, or just add a tint on debris. So debris would be like.
So that like simulates going into creases and stuff?
It doesn't do any simulation. It just goes and grabs those data. So we already have generated those data in erosion.
From the erosion.
Yeah, it grabs from erosion. In erosion, we have generated those data, debris, bedrock. So it goes and grabs those maps from that. So let's keep it as a cold mountain. And another texture, let's say you add water, and it's add another tint, or again texture. You can load blah blah .jpeg or PNG or TIFF or whatever, or let's add water, deep water over there, greenish. And then, so you've done a quick shading, and yeah, it's nice. You can boost up the resolution. How? So let's say you're happy with the result, but not with the resolution. So you can use a. We have height field. What was that? Resample. That's the one. So resample it, so like you can make it 2 times more dense. Look at the so 0, oh sorry, 1, let's go 4. Yeah, a lot of data will be added, so you have a more dense information over there.
Is that better than decreasing grid spacing in the HeighField mode itself?
Like breaking voxels, softening edges, like the same principle that we have for the volumetric. So we have a voxel that size. Let's say we convert it into, it's 1, we turn it into 4 voxels, and then start to like,
It's like, okay, redividing them after all the other.
yeah, after all. So if you want a really dense, so this one, so let's say you get, oh, that's too much. So let's say you get 114 megabytes out of resampling. So it's 7 megabytes, but then you get 114. So let's say if instead of, so we yeah, by 4. Let's do it before the process. So if I go to the beginning here, instead of 1000 by 1000, I make it 4000 by 4000. Why I don't see any? I think I have to cook the erosion again. So let's go to the erosion data. Simulation, reset simulation. Okay, it's thinking, it's cooking the simulation. I'm gonna pause the record, continue. So it's been cooked. I think we have to play the erosion once more. So you see that it's slower, but it's much more. So what is the amount of information we got now? If I stop it here, it's 118 megabytes. Pretty much the same, I don't know. So it seems that it doesn't matter if you resample it after or before. Memory wise, yes, it's better. Well, memory wise, it doesn't matter, probably. That's a theory, hypothetically. But workflow wise, you definitely have to resample because you want a nice and clean playback.
Isn't that making it more blurry than doing it before?
I don't know. So we can compare. So yeah, it seems sharper if we do it before.
It should be sharper because you're applying the noise and erosion to something
Yeah.
that's already subdivided.
Yeah, you're right. You're right. Yeah. If we resample after that, it actually does a lot of blurring and stuff. So yeah, we have a much sharper train now. Yeah, you're right. So yeah, applying a large, as long as you have resources available, like a good computer, you can start with a large height field, but otherwise it's better to resample at the end. And you can, one really cool feature, so that's resampling. I just delete that one. Yeah, I just want to bring it back to 1000. Don't, because that's quicker, faster. Oh, come on. Let's go back to the HeighField distortion. Erosion. Reset simulation and play. Oh, why? There's something wrong. Anyway, One really good feature here, that's our quick shade, is so let's say we start branching from here, and I want to add HeighField mask draw mask, or mask draw, yeah, draw mask. That's a very useful tool. You can draw a mask wherever you want. So let's say you want to apply some specific thing on this area, and this mask is like sharp, so you add a blur around it as well, so it gets blurry. Oh, you just want to blur the mask, not the HeighField. Yeah. So you have a nice mask here, and you can use it for different features. Let's say you want to distort, or let's talk about something new. So a terrace, HeighField terrace. So that one creates terrace here and there. So you see that it just makes the steps. I can say go and grab that mask. Oh, but why it doesn't grab the mask area that we want? I don't know, I have to figure that out. Oh, mask layer. Let's call that mask 2. And here I use mask 2. Why didn't get applied on that? Anyway, I have to figure that out. I probably have missed something. But yeah, that masking some specific areas. Let's go back to the mask instead of mask 2. Yeah. So you see, you can invert your mask, or just grab a mask. That can be used for a lot of operations. And one last thing that is really useful for so let's say you want to apply a terracing on this HeighField. So we just talked about most of the things like masking. So a lot of things is quite obvious. So if you have an object and you want to mask it based on that object within so let's say we have, so that's one of the tools that you can connect a geometry to your HeighField. Let's say you have a sphere, and that sphere is so it should be massive because HeighField is massive. Okay, so let's say make it 300. Yeah, and mask by object. So you see that one of the nodes has different colors, so it means that it accepts an object. So this area is being masked with that object. So, and you can keep using that mask like the other masks. So let's say if I just can add, I don't know how. Let's say you want to add a terrace, and that terrace, so is that the mask? Yes. So grabs the terrace from here and the mask from here, and let's minimum maximum height, mask height layer height or mask. I don't know, for some reason that doesn't work. Height layer height. Or maybe I should apply it before shading it. So this has been masked, and before erosion actually. Control B. I'm gonna attach it to the noise. We have that mask over there, and I want to create a terrace or HF terrace, and that one is going to apply on that. So this applies on everywhere. It uses, so it just applies on every part. I just have to find the right size. Cliff mean slow. What was that? Maximum height. Yeah, it should be. Why it doesn't like me? That softness. There was something compute range. Oh, sorry. How stupid I am. We should have computed the range, and it just does the rest for us. So it just applies the terracing on everything. But then we can say, so maximum, minimum, so it can go right up to the end, or just have a maximum, minimum size. I can say okay, and the mask comes from here. So you see that, okay, now we know what the problem with the previous one. So you see that the masking comes from an object that has been used to mask out a part of the image, and that one can be blurred as well. HF blur here, and you will see that area. So if I increase the, why it doesn't get border value? Oh, I'm masking the height, not the blur. Okay, now we are good. Okay, now we can apply the erosion on that one. So you see that that's a cool effect actually. Yeah, I like it. So let's have our own erosion applied on this one now. So let's go to the erosion is at frame 24. Click on that. It should recalculate that, reset the simulation. Let's. Okay, no, it doesn't. It's okay. Now we have another set of attributes added. Yeah, that's it. So the way a pipeline for the train building works is to start with like adding noises. So you can group them together. So it's actually just start with building up layer by layer. So you build up your debris and then water layer, and then bring them together using a HeighField layering, or HeighField layering and resampling at some point. You can paint masks. You can mask based on features. So let's say that's a really useful tool as well. So let's say I'm grabbing from here HeighField mask by feature. So this one will, so you say I'm gonna mask based on the slope, or I'm gonna mask based on the height.
Mask based on the sharpness of edges. Like
Peaks and valleys, we have that one, and direction, but sharpness of the edges. So the sharper gets masked. So a slope should be something like that. Slope is like, so let's say, so now lower slopes has been masked. What you say, you want the higher slopes to get masked.
actually, okay, my problem was that when I tessellated my HeighField,
Okay.
since I have limited processing power, right? My HeighField, whatever its resolution is, the tessellated mesh padding after that has like jagged edges where the edges are, sharp angles.
Ah, I see.
Because, well, everywhere else I don't need that much resolution, but where I got like a cliff with a 90-degree angle, I need a lot more resolution in this place.
I see what you mean. But this is what I.
For way to tessellate it more in those regions.
So if you go for higher slopes, does it help? So you see that it grabs those areas that has the highest sloped.
But that's actually where you need less tessellation, so maybe the negative of that.
So like the other way around. Like that? Oh no, that doesn't help. What about inverting it?
There must be like some quick math that can be done, like
Yeah.
derivative of the slope.
Slope of, yeah. And then, so combining two mask by feature, one of them from the other side, the other one, and then cut it from height.
But what if you wanted?
So let's say, look at here.
That's gonna only do it at the limit of one type of slope, right?
That's what I said. So this, I grab this part, and then I add another mask by feature, and this one does, so that one was like, so let's do it 50 by 60, okay? The other one is 60 by 50. So, oh no. And then we layer them, HeighField layer. No, I was wrong. My theory was wrong.
Oh, but yeah, that's gonna be a thing like that.
Yeah. So I was thinking if I would, because
The thing is, if you just make the difference between one slope angle and another slope angle, you'll get the limit between those, but you won't
yeah.
get all the limits.
Yeah, you're right.
All the sharp edges.
Yeah, you're right. That's a challenge. That's a good.
That's gonna be something to do that. Right?
Yeah. Of course there is. It's Houdini, man.
Well, yeah. The only thing I can see would be to derivate the slope, but there's gonna be something
Yeah.
like a node or.
Yeah. That was a very basic introduction to train building using HeighField. It's easy and nice to work around with. Thank you so much.